What if the emptiest place imaginable is not truly empty at all, but restless, structured, and physically capable of leaving measurable fingerprints on the matter placed inside it? This is not poetic language. Quantum physics treats empty space very differently from everyday intuition, and one of its strangest lessons is that a vacuum is never just blank nothingness. In 1997, Steve Lamoreaux reported a measurement of the Casimir force, one of the clearest experimental signs that the quantum vacuum can influence how nearby objects behave. That result mattered because it did not rely on mystical language or speculative philosophy. It showed that what looks like emptiness can still participate in measurable physical effects inside an ordinary laboratory setup. In classical thinking, a vacuum means nothing is there. No particles, no medium, no activity, no hidden structure. It sounds like the cleanest and simplest idea in the world, but quantum field theory changes that picture immediately. Even the lowest energy state is not a simple void stripped of all physical significance, organization, and lawful consequence. Fields remain present, fluctuations remain possible, and under the right conditions, the structure of that vacuum changes what matter is allowed to do, measure, exchange, or resist. The Casimir effect is the famous doorway into this story. Place two conducting surfaces extremely close together, and the allowed vacuum modes between them differ from those outside. The result is a tiny force pushing the surfaces together. Not because hidden air is trapped there, not because of dust, pressure, or ordinary classical contact between microscopic objects, but because the quantum vacuum is structured enough that changing its boundary conditions changes the physical outcome. Empty space, in that sense, stops behaving like a passive backdrop and starts behaving like an active participant. Lamoreaux's experiment did not prove every popular story told about the vacuum, but it did help show that the properties of apparently empty space can be tested rather than merely imagined. This is where language becomes dangerous. Many people hear virtual particles popping in and out of nothing and imagine little microscopic sparks appearing from absolute non-being, like a cosmic magic trick. That image is memorable, but it can easily mislead. Different mathematical formalisms and interpretations describe vacuum phenomena in different ways, and not every physicist likes the same metaphor. So the careful version is better. The vacuum is not empty in the everyday sense. It is the lowest energy state of quantum fields, and that state still has consequences. Those consequences reach beyond one laboratory result. Vacuum structure appears in calculations tied to atomic behavior, quantum electrodynamics, and subtle energy shifts that increasingly precise measurements continue to uncover. The Lamb shift, spontaneous emission, and other quantum electrodynamic effects all sit inside a worldview where fields never quite vanish into the simple silence classical intuition would prefer. It also reaches into cosmology. Discussions of inflation, early universe expansion, and vacuum energy all depend on the fact that physics does not treat emptiness as mere absence. So, when people ask how something could come from nothing, physics immediately forces a harder question. What do we actually mean by nothing, and are we using the word consistently? Philosophically, nothing means total absence, no laws, no fields, no possibilities, no background, no structure at all. That idea is more radical than most scientific conversations usually mean. In physics, by contrast, nothing often means no particles present in a region, while fields, symmetries, and lawful behavior still remain in place and continue shaping what can happen there. That distinction changes everything. A universe emerging from a quantum vacuum is not the same claim as a universe emerging from absolute non-being, and collapsing those ideas creates more confusion than clarity. And this is where mainstream scientists become very careful, for good reason. The vacuum does not prove mystical creation, and it does not let us bypass the hardest metaphysical questions. It does not tell us why there are laws rather than no laws, or why quantum fields exist rather than nothing at all. Physics can describe behavior here better than it can explain ultimate origin. But it absolutely does destroy the naive picture of emptiness as inert blankness. Even the darkest reaches between galaxies are not simple voids in the way common sense imagines. They are governed by quantum fields. They permit fluctuations. They can influence interactions. And they remind us that silence in physics is often full of hidden structure. This is why the vacuum belongs among the strangest ideas in science, not because it invites fantasy, but because it makes measured reality less intuitive than fiction sometimes sounds. When you look into black space, you are not looking at an absolute absence. You are looking at a regime where the lowest state of reality still carries physical content. Particles may be absent, yet the stage remains active. The grammar of the universe is still there, even when the sentence briefly appears blank to human intuition. That realization also changes how we think about origins. If emptiness already contains law, possibility, and structure, then the question of beginnings becomes deeper, not easier. The vacuum does not end the mystery, it sharpens it. Why do these fields exist? Why these laws? Why should the lowest state of reality be ordered at all? Science can describe the behavior with extraordinary precision, but description is not the same as final explanation, and honest physics never pretends those are identical. Still, one conclusion is unavoidable. The universe may have been strange long before stars, planets, life, or consciousness arrived to notice it and give it names. And if this thought was worth sitting with, share it with someone who still thinks emptiness means nothing at all, because the vacuum may be one of reality's most active silences.